All right, in this video, I want to solve these exponential equations over here. Now, what you'll notice in these examples is that we have an addition in one of the exponents, and then we just have the same base on one side. You can see the same pattern in both questions. So whenever you have an addition or subtraction in the exponent, you want to start by first splitting this up using your rules of exponents. So I can split this into 5 to the power of x times 5 to the power of 6, because if you're adding in the exponents, you can split them up into two terms and it'll just turn into multiplication. We have minus 5 to the power of x equals to 390,600. The next thing you want to do is you want to common factor out of 5 to the power of x. So if I factor out 5 to the power of x here, I'm left with 5 to the power of 6 minus 1. Basically, I just divided both of these by 5 to the x, and I get 5 to the 6, and then there's only a 1 left over here. Next, you want to do this calculation in the bracket. You want to use your calculator, obviously, because it's a pretty tough calculation. So 5 to the power of 6 minus 1 is 15624. And then you want to divide this number on both sides. We get 5 to the power of x equals 25, and this is pretty easy to solve. You know that 25 is just 5 squared, and now the bases are the same, so we can cancel them. So x equals 2 is the solution. Let's take a look at the second question here. It should be the same steps. It's pretty simple. I'm going to start by splitting this into 2 to the x times 2 to the 7 plus 2 to the x equals 4128. Then I'll common factor out 2 to the power of x, and I'm left with 2 to the power of 7 plus 1. I'll do this calculation in my calculator. 2 to the power of 7 plus 1 is 129. Divide both sides by 129. Get 32. And I know 2 to the power of 5 is 32. And I can cancel my bases, and my final solution is just x equals 5.